Hello, everyone. Okay, I'm Ferran. I'm from Flashbots, and I'm gonna be talking about the RBuilder. The RBuilder is the new block building stack that we have developed at Flashbots. So, how many of you know how PBS works? Raise of hands. Not that many. So, this is how PBS works. So this is how block building works. Oh, doesn't point. At the top, you have in green, you have the normal block building workflow. You have the proposer, which will delegate to the execution client the build of the block. So the execution client will use vanilla block building algorithms to return a valid block to be proposed. And here at the bottom is what we call the PBS, or proposer-builder separation. Now we have two more actors. On one side, we have the builder. So builders will build blocks for the slots. And the proposers now will call the MEV boost relay to sort of serve as an impartial auction to select which block is willing to bid higher for that slot. So the MEV boost relay here also adds extra security in case of the proposer not being able, though they might be able at the end, but not being easy for the proposer to unbundle the block of the builder. So what I'm going to be focusing on this talk is that actor of there, the builder. So all this stack was introduced, this PBS stack was introduced by Flashbots right after the POS. And we initially open sourced the MEV boost relay implementation, and then we also open source block builder implementation. So this was a fork of Go Ethereum with a more complex merging algorithm, and also all the bindings required to send bits to the MEV boost relay. This sort of open competition got competitive at some point, and more sophisticated players started to enter the block building competition. So you'll have, for example, trading shops with custom order flow that could build more valuable blocks. Most of them will follow the same process. They will take the builder, or they will fork it and add their own changes on top. These are the four main categories that we have seen so far where they have introduced changes. They, as I mentioned before, they have internal order flow that they can leverage, so they modify the builder for that. They may introduce new latency improvements, like connecting to the relay using web sockets. They can use new bidding strategies to decide how much they want to bid for the block. And to sort of combine all those three, they build custom merging algorithms. But again, all of them follow the same process. They take the client, they fork it, they add the changes, and they upstream. And I'm not sure how many of you have been in that situation, but that's really complex to do at scale. It creates some sort of psychological fear every time you try to create a new feature, because you don't know if Geth is going to break some interface or what you're doing is going to be available for the next release. Okay, yeah. So we were in the situation as well, and we saw how we were not innovating in block building. And right at that point, we were thinking, okay, how we are going to update our builders? What's going to be our newest strategy for block building? And with the release of Reth, it was easy to think, okay, how we can leverage Reth for that. And the way we can leverage Reth is using its modularity. So it's important to note that Go by itself, by the way Go works, it's a modular language. You can already take code from Go Ethereum and using it as a module. Most people use the EVM inside Go Ethereum. But just because you can use that module doesn't mean that it's going to be easy for you or it's going to be maintainable for you. There has to be some kind of contract in that API for you to safely and in a scalable way to use it. And that's what Reth offers. With the crates of Reth, we are sure, though they can be breaking changes at some point, that they acknowledge that modularity is a first-class citizen of the system. So they are willing to put some API contracts there that they are not going to break those implementations. So following that, that's when we started the RBuilder. So the RBuilder is a modular block builder built on Reth. It's built on Reth. That means that as the common layer uses Reth, Reth primitives, Reth provider, and the alloy types, and that helps us to like remove a lot of extra code that we don't have to do anymore on the builder, like typings or encodings. And it's modular in the sense that we want to bring the same innovation that Reth is bringing to the nodes client into block building. We want to make it easier for people to take the RBuilder and create their own sorting algorithms, merging algorithms, add new functionality without having to go through the cycle of forking, merging, upstreaming. Okay. So how is it going so far? Oh, sorry. This is how the RBuilder works right now for the L1 use case. So this is the same picture as before for the PBS example. And now we have the RBuilder that it's connecting with the Reth database to sync all the estate. So to do that, we just use the Reth crates to connect and access that database and get a reference that we can pass to the AVM for the RBuilder. So how is it going so far? As of now, as 2 months ago, we don't run any more Go Ethereum nodes. We just deprecated all the Go platform of the block building, and we only use these RBuilders. They're way more efficient than it was before. And half of them run in this TE platform. So TE is another angle of Flashbots that I won't go into detail, but if you have more questions, come talk to me afterwards. TE is a special type of hardware that is a security enclave where you can run your applications. So half of our builders, and by the end of the day, we want to be all the builders, are running already in this TE platform and with negligible performance. We are talking about 5% to 10% loss in performance. Which are the features that I want to highlight? First, as I gave a hint before, is a modular block building. That means that there is a trait that you can implement to add your own custom merging algorithms. You might have new strategies for DAG sorting or some simulation or some heuristics that you can easily plug into the RBuilder, test them out, and send blocks into the L1 chain to see how it looks. Combined with that, we have backtesting. So you can easily check how does your algorithm works, how is improving. You can take a range of blocks from mainnet and see if you are increasing the value that you are generating, also pretty easily. And the third point, and this is something we just open sourced a few weeks ago, we have a local deployment environment. As I showcase here, in order to test the RBuilder, you have to basically run these 3 and sometimes 4 different services. So that was a huge struggle sometimes when we wanted to do local testing or some CI integrations. Now we have a complete local playground. It's on GitHub. It's called Builder Playground. That takes 8 seconds to deploy all that setup, all in memory. Pretty easy to do. So that has helped a lot into testing new features and on the CI integration, and we hope to leverage that to increase more the coverage of the builder. So where are we going from here? These are the 4 major tracks that we are going to be working on for the next months. First one, and that's the one I'm focusing on, we are adding multi-chain support. The same way that Reth can be a node for both mainnet and OP chain, OP stack. We want the RBuilder to also be a builder for L1 chain and also for OP chains. So we are researching how we can make the builder modular to support these use cases. We want to improve block builder architecture, so we want to also research what is the most efficient trait architecture for the builder to support many different block building use cases. Third one, this was mentioned yesterday, is that Reth it's not still as efficient as Go Ethereum doing state root calculation. In our benchmarks, we have get block builder at 15 milliseconds for hash root calculation, and right now with RBuilder it is 100 milliseconds. So we are merging in the next 2 months a new hash root calculation improvement that brings down the number to 10 milliseconds. And the last one, which I'm the most excited on, we are going to launch a block building competition. So we want to launch like a sort of Kaggle block building competition when people can send their own block building algorithms, train them in some snapshot of training data, and then we'll run them on some test data and create a leaderboard on top of that. So yeah, if anyone wants to try, be on the look for the competition. Yeah, thank you.
Hey, yeah, thank you for the presentation. I have a more general question about how you backtest. I'm curious because I've been talking with friends, or you just said it here, like usually how you backtest is like you take a subset of blocks and you replay them and you see like how performant it was. I'm curious, like it seems very constrained. Like I'm curious if you have other ways to make, like to attest of the quality of your improvements.
So you don't test on a range of blocks. You have to test on the, you have to sort of replay the state at which the block was built, right? So you have to, at point t, you have to start with a state t-1 and all the transaction that the mempool had at point t, right? Because that's the state that the RBuilder used to create the block eventually. Not all those transactions at point t are gonna be end up on the block, right? Yeah. So we have a tool called mempool dumpster, which is also from Flashwatch, which just has, it's like an S3 bucket that holds all the transactions that were in the mempool at different points in time. Right? So if you combine that with an archive node, you can really start to replay a given range of blocks and see how your builder performs. So part of the thing that we're trying to do is sort of ease those requirements to run those backtesting, so you don't have to require an archive node. So we are testing like different strategies there to make it easy for people to run it.
But if you have a different behavior, wouldn't it mean that it would change also the behavior of potential other builders on the network or other actors that would also behave differently if you had a different behavior? Which means that your backtesting is valuable in a sense because in this contrived environment you can say, okay, I'm X% better, but it's not like real world testing. So that's why I was just curious if you had like other ways of testing than that.
Yeah, I don't think we have you will have way to test how your strategy plays out with different block builders. I think this backtesting is only to test what's your baseline, on top of which you can start to compete with other builders. But that would be something different.
Thank
you. In your diagram up there, I noticed that RBuilder communicates directly with the Reth database.
Yeah.
Can you elaborate on how the Reth communication itself works and why not just run in process with Reth?
Okay, yeah, that's a great question. So, well, the way you plug into the database is because of MDX. You can just plug in read mode inside the database. And why we don't make it as a module? We are actively working on that. I think part of the modularity of the RBuilder will be on how you can create different flavors of it, and maybe one of those flavors run it as a module. This current architecture is helpful because the RBuilder does not depend on the chain syncing, right? So you can have the Reth running and syncing the chain, and then you can just restart the RBuilder as many times as you want. While if you have it in the same process and you stop the whole process and then you restart again, you'll have to wait for that chain to restart, even if it's like 10 blocks, right? So by having it separated, we don't combine those life cycles. But I agree that with making it as a module of Reth, it brings like other benefits, like piggybacking a lot of like memory and cache improvements that they might do in the future. So that's something that we are actively researching.
that's it. Thank you. Okay, next up we have Alex Stokes from the Ethereum Foundation talking about MEV-RS.
Hey everyone, good afternoon, and yeah, this will pair well. It's a very similar take on